Hello, grade 9s. Today we're going to talk about 6.5, which is all about inscribed angle properties. Now, when we talk about inscribed angles, we've already defined what they are. An inscribed angle is an angle formed by two chords that meet at a point on the circle. So remember, a chord is just a line segment that has endpoints both on the circles. So an inscribed angle is formed by two chords that have that common meeting point on one of those two ends. Now, when we talk about inscribed angles, some cool properties exist and take place as a result of them. So we have three inscribed angle properties that we're going to be talking about today and seeing how we can use them to help figure out some unknown values in a circle diagram. So, inscribed angle property number 1 has to do with inscribed angles and central angles. So when an inscribed angle and a central angle intercept the same arc, the measure of the central angle will be twice the size as the inscribed angle. And we can see that written in somewhat of an equation form here. We have m representing the measure of. Here we've got a central angle, and it's 2 times as big as the measure of an inscribed angle. We can also say that reversed. So instead, we could say the measure of an inscribed angle will be half of the measure of the central angle, really depending on what we're provided with is going to help determine which direction we're treating this in. Now, just to kind of see what that looks like on a diagram, here we have an inscribed angle that I'm now highlighting in purple, and this point here, let's say it's I. So I have angle AIB being an inscribed angle. We also have a central angle that has the exact same endpoints, which is where we can say it intercepts the same arc, because both the inscribed and the central angle cut this arc out of the circle. And so central angle, we'll call that middle point C. So we have angle ACB as my central. We can use the property to say whatever the value of my inscribed angle is, the central will be 2 times bigger. Or we can say the central angle, whatever the value of that central angle is, the inscribed angles will be half as big. Now, let's take a look at some diagrams here. We, in these examples, are going to not only determine the measure of the indicated angle, the one that we're looking for, but we're also going to explain how we know. And explain means using words. So when I take a look at this, I want to see what I've got first. And I've got, that's much too thick. I've got angle AOB. And angle AOB is a central angle, and it measures 80 degrees. I also have angle ACB, in which I'm looking for, and it's an inscribed angle. I know that they're on the same arc, they intercept the same arc, so I can use that angle property we just talked about, which leads me to know that the measure of angle ACB, the inscribed angle, will be half as big as the measure of the central angle. So I have 80 degrees divided by 2, which gives me 40 degrees. Now that's the measure of it that I've indicated, that I've determined. Now I have to explain how I know. The inscribed angle ACB will be half the size of central angle AOB, since they intercept the same arc. So I find my solution and I explain why I'm able to figure that out, or how I'm able to figure that out. All right. We are going to do similar things to the next example here. We're going to see what I have. So I'm told the measure of angle DEF, which is an inscribed angle, and I want to find the measure of angle DOF, which is a central angle. And we know the relationship between inscribed and central angles that open the exact same arc or intercept to the same arc. So I know that the measure of angle DOF, that's central, will be 2 times the measure of the inscribed angle, which is 34 degrees. So the measure of angle DOF is going to be 68 degrees. Similarly speaking, we can explain how we know. The central angle DOF will be twice the size of inscribed angle DEF, since they intercept the same arc. Okay, now when we take a look at any of these explain questions throughout the unit, explain does mean in words, and explain has to be crystal clear. We can't just say the central is double the inscribed, because that's only true if they intercept the same arc. And we can't say the inscribed is half the central, because it's only true if they intercept the same arc. So having both components is 100% necessary and is what you will get your mark for. You will not get a mark for explaining something if you only include part of the explanation. Okay. Next example. So in next example, we have a circle that has center C. So I'm going to go ahead, label that C. And it has a radius of 12 centimeters. Now, angle XYZ is an inscribed angle with a measure of 45 degrees. So I'm going to draw an inscribed angle. And remember, an inscribed angle is formed by 2 chords, X, Y, Z, and I know it's 45 degrees. So that's the information given to me in the question, which I've now drawn on my circle to the right. Now I want to do a couple of things. Thing number 1, I want to state the measure of angle XCZ. XCZ, well, that's a central angle. And my central angle and my inscribed angle intercept the same arc, which means that angle property of my central angle being double or twice the size of my inscribed angle will hold true. So the measure of angle XCZ will be 90 degrees. Now, something to keep in mind. I realize that this angle does not look like a 90-degree angle. The way that I drew it, I didn't know that I was about to draw this to be a 90-degree angle. I just drew as best as I could. Now, oftentimes, if your diagram does not match perfectly, it's not the end of the world, because we're using the diagram to help us figure out the math. We don't have the math first to then perfectly draw the diagram, then to figure it out. Because if we knew what it was going to be, why would we need the diagram to begin with? So I wouldn't fret too much about my diagram not being super perfect here. Okay. Fun little bit while we're here is that I can go ahead and label that information on here. So I'm going to label this as 90 degrees. And in my question, it also said that I had a radius of 12 centimeters. And now that I've drawn some radii, remember that's a plural of radius, on my diagram, I'm going to label them. So both of these are 12 centimeters. I'm going to indicate that with a matching tick mark to show that they're the same. And this is what I've got. Okay, next I want to figure out the measure of minor arc XZ. Now, this is minor arc XZ, which we actually have learned from last time can be found if I know the measure of the central angle that intercepts it. Because from the last lesson, we learned that the measure of the central angle is equal to the measure of the minor arc that it intercepts. So if the central angle is 90 degrees, that minor arc will also be 90 degrees. Next, we want to state the measure of the major arc, XYZ. Well, that's this part over here. Now, I know a whole circle, a full rotation angle is 360 degrees, and if the minor arc is 90 degrees, the major arc is the difference, the remaining of it. So 360 minus 90, or in this case, 270 degrees. Last but not least, it wants us to state the length of XZ. Now, with no symbol on top, we know that that indicates a way to represent a line segment. So I can represent it with that line on top, or line segment on top, my apologies. But that's what I've got. Now, when I take a look at this, this is the value that I want to find the measure of. Now, I might think to myself, I don't know how to combine angle measures and side lengths. But what else I might also see is, hey, hold on, I have a right triangle there. I have that 90-degree angle, and I know 2 of the 3 side lengths. Can I find that remaining side length? And the answer is, of course I can. I can use Pythagoras. Now, Pythagoras could only be used knowing that I have that right angle triangle. So if I didn't know that that was 90 degrees, I would be out of luck. I could not do that. But because I do, I can proceed. Now, I know my hypotenuse is the side across or opposite from my right angle. So XZ goes in the position of C. And those other 2 sides, the 12s, will go in the other 2 positions, A and B. And I could do the math. Now, I will need a calculator for this. I'm not going to pretend like I'm able to figure out the square root of whatever my final answer looks like. But the first step we can probably do without a calculator. 144 plus 144 is segment XZ squared. And 144 plus 144 is 288. And to get rid of a square, I can square root both sides, where I end up with the square root of 288 is equal to XZ. But I don't know the square root of 288 off the top of my head. So I'm going to plug it into my calculator. And I'm going to round to 2 decimal places. And I get 16.97. And my units are centimeters. Why centimeters? Well, because my radii are given to me in centimeters, which means my final answer will also be in centimeters. So the measure of side length or line segment, XZ, is 16.97 centimeters. So that is property number 1. And the cool thing about property number 1 is that we can blend it with some of our other known facts to start looking at a little bit more of an advanced type of question. But each step is not difficult in itself, but just something that I'm continually building on. So the challenge in this unit is not necessarily the individual steps, but the building of each step to give us a more complex answer. Okay, property number 2. So property 1 was about inscribed angles versus central angles. Property number 2 is inscribed angles with other inscribed angles. So when multiple inscribed angles intersect the same arc, the measures of each inscribed angle will be the same. So when I look at the diagram to the right, I have 3 inscribed angles. This orange guy, the green guy, and the blue guy. And they all intercept minor arc AB. Which means if I know the value of one of those inscribed angles, I know the value of all of the inscribed angles. They will all be the same. The measure of the 3 inscribed angles, or 4 or 5, however many I have, will be equal. Okay, let's take a look at an example. So before I even start take a look at this example, I like to take a look at the diagram and see what I've got. So I can see that I have an inscribed angle here that opens up to arc AB, or intercepts arc AB, and I know the measure of it to be 35 degrees. What I want to do is I want to find the measure of angle ADB. Now, angle ADB is also an inscribed angle, and it also opens to the same arc, which means the measure of angle ADB will also equal to 35 degrees, because these 2 angles, the inscribed angles, will be congruent, the same size and shape. Okay, how do I know? Because I should say angle, I hope you caught this. I wrote ABB, but I meant to write angle ADB. So let's fix that. Okay, explain how I know. I know because angle ADB and angle AEB are both inscribed angles that intercept the same arc, so they are congruent, or the measure of those angles are equal. So angle ADB and angle AEB are both inscribed angles that intercept the same arc, so they are congruent. Lovely. Next, I want to state the measure of angle ACB. ACB. And in my diagram, I'm noticing ACB is a central angle, but also intercepts the same arc. So I know I'm not going to be talking about property 2 here, because property 2 only relates inscribed angles with other inscribed angles. But the property 1 we just talked about indicated what happens when inscribed angles and central angles intercepted the same arc. So I can use property 1 to help me out here. So I know that a central angle like ACB, when it intercepts the same arc as an inscribed angle like angle AEB, it will be twice the size. So it'll be 2 times 35 degrees or 70 degrees. It tells me to explain how I know, so I need to do that. Angle, or I should say central angle, ACB, and inscribed angle, AEB, intercept the same arc. So the central angle will be twice the size of the inscribed. Now you might be thinking to yourself, okay, Miss T, I get it. I included both of those two components into my explanation. the component of those angles needing to intercept the same arc, and the component of how their sizes compare to each other. But I wrote it a little bit differently. Is that okay? And the answer is, of course, yes, right? Even if I wrote this out 100 times, I would likely say it a little bit differently every single time. As long as I have the same key information, then I am more than okay. All right, next example. So in this first one, I have circle that has a center O and is represented by the diagram below. I want to state the measure of angle LPN. Well, before I do any of this, I'd like to see what I've got already. And I know angle LMN, I can see that's an inscribed angle. It opens up to this arc here, LN, and it's 55 degrees. Now, when I talk about what I'm interested in, I'm looking for LPN. It's also an inscribed angle, and it also opens up to minor arc LN, which means the two measures of those two inscribed angles must be equal. So the measure of angle LPN is equal to 55 degrees. Because they're both inscribed angles that open up to the same arc, that intercept the same arc. Now, it doesn't actually say explain how you know, so I'm not going to. It doesn't ask me to, I'm not required to. In the next question, it says state the measure of the central angle, LON. So I'm going to draw LON first. So LON. And I know it's a central angle. I mean, granted, it does tell me in the question. But I know it's a central angle because I can know that O is the center of the circle. And I know that the relationship between central angles and inscribed angles on the same arc are such that the central angle is double the value of the inscribed. So I'm going to have 2 times 55 degrees, which is 110 degrees. Now, this one does tell me to explain my reasoning, and I am going to say something very similar to what I said above. Of course, my wording might change slightly, but I'm looking for commonalities here because it's the same property. Okay, so I'm going to say angle LON and angle LMN intercept the same arc. So central angle LON will be twice the size as inscribed angle LMN. Now, I intentionally wrote this with slightly different wording than the example above that I've also starred. Because even though I could have just changed the angle names, I wanted to point out that as long as I have those two key components of those angles intercepting the same arc and the size comparison between the two, then I am more than okay. Right? The order that I write that doesn't make a huge difference. So I had angle LON and angle LMN intercept the same arc. So central angle LON will be twice the size as inscribed angle LMN. Last but not least, I want to talk about the measure of the minor arc, which is LN, right here. It also tells me to explain my reasoning. Well, I know the measure of a minor arc will be equal to the measure of its central angle that intercepts it. So I know if the central angle is 110 degrees, the minor arc will be 110 degrees. So the measure of a minor arc is equal to the measure of the central angle that intercepts it. The measure of a minor arc is equal to the measure of the central angle that intercepts it. Whew. Okay, we've gone through 2 of the inscribed angle properties so far, which means we only have 1 left. And the last one is pretty cool. It talks about inscribed angles and semicircles. Remember, we've already talked about what a semicircle looks like. And a semicircle, it really just means half of the circle. So it's not quite a minor arc, it's not a major arc, it's exactly half the circumference. So an inscribed angle that intercepts a semicircle is a right angle. Now this kind of makes sense in many different ways, but let's take a look at my diagram. So I have my inscribed angle right here. And I can see that it's intercepting a semicircle. And I know that because that diameter is the central angle in this case. Okay, so I can see that it forms a 90-degree angle. Now, why is that so neat? Why is that so useful? Well, remember, an inscribed angle is half the measure of a central angle. So the central angle is the diameter. And a diameter is just a straight line or a straight angle. So that central angle is 180 degrees. An inscribed angle is just half of it, which is 90 degrees. So realistically, this property isn't a new property, right? It's just me interpreting that a semicircle is created by a diameter and that a central angle is twice as big as an inscribed angle that intercepts the same arc. I'm just putting those 2 ideas together. But it is technically our 3rd property. So let's take a look. We have 2 examples left. Point C is the center of a circle with a diameter AB, which is 10 centimeters long, and chord BC, which is 6 centimeters. Oops, I think there's a typo here. It should be chord BD, because BC wouldn't be a chord, it would be a radius. What is the measure of angle ADB? Explain your answer using 2 different explanations. Okay, so way number 1 is just the property that we talked about. If this is the diameter, then that means that we are intersecting a semicircle, okay? So angle ADB is going to be equal to 90 degrees. I should say the measure of angle ADB is equal to 90 degrees. Why? Well, way number 1 is I can say angle ADB is an inscribed angle of a semicircle. That is method number 1 for me to justify or explain my reasoning. Way number 2 is that the central angle, which is angle BCA, is 180 degrees and intercepts the same arc as inscribed angle or ADB. The order doesn't matter. So the inscribed angle will be half the size. All right, so we've got two ways to indicate that. And now that I know I'm talking about a 90-degree angle here, I'm actually going to draw that in. So there's my 90-degree angle. Now my next question is, what is the length of chord AD? Well, this is AD over here. And remember, the only way we've talked about finding the length of a chord so far is if I have Pythagoras, which means I need a triangle that has a 90-degree angle. And lo and behold, we have that, right? I have triangle ABD, and I know 2 out of the 3 sides. So I'm going to redraw that triangle just so that it's here. Okay, I know that this is 6 centimeters, this is 10 centimeters, and I know DB A exists, so I can use my Pythagorean theorem. Now, Pythagorean theorem, a squared plus b squared is equal to c squared. And I need to make sure my hypotenuse goes in the spot of c, and my hypotenuse is always located across or opposite from my 90-degree angle. So I know c has to be 10, which means a or b can be the 6 and the unknown. So I'm going to put 6 in the B spot just because, to be honest, I probably would have confused the lowercase b for a 6 anyways. And my remaining side is line segment AD. And I'm going to do the math. Well, I can simplify the left-hand side here. That's 36. And I could simplify the right-hand side, which is 100. And I'm able to isolate my unknown by reverse operations by using subtraction to undo my addition. So I get AD squared is equal to 64. And I could continue my reverse operations to undo the square to get my line segment AD is equal to 8. And again, matching the units that are provided to me in the question. Since the 6 and 10 were both measured in centimeters, my final answer should also be measured in centimeters. Okay. This last example. Now, this last example, before we even do anything, we don't have to do any explanations. We are simply going to figure out the values. Now, just so that we're clear, I want to talk about where these values go. So I have an inscribed angle, PLN, which measures the 68 degrees. Okay, so inscribed angle, PLN, 68 degrees. I also have this arc, which measures 92 degrees. It's a minor arc because it's between 0 and 180, but just wanted to point out where those numbers are associated. Now, we're going to go through these one at a time. I'd love if you could pause the video and try some of these for yourself, but either way, I'm going to do them with you. Okay, so the measure of angle PMN. So PMN is this angle here. And I can see it's an inscribed angle. It's made out of 2 chords. And I noticed that it's an inscribed angle that intercepts the same arc as my other inscribed angle. And using property 2, I know that that must mean that this angle here is also 68 degrees. Okay, next, I want to figure out the measure of arc PN. Now, something that's really important here, there's actually only 2 times where we talked about figuring out the measure of an arc. And way number 1 was saying, okay, if I know the rest of the circle, then I can figure out a component of it. Because I know all of the arcs in a circle will add to 360. So if I had the yellow part, the green part, and that remaining chunk that's unhighlighted and unlabeled, I can figure out the yellow. But that's not a pathway I can take at this point because I don't know the remaining chunks. Like I don't know this chunk of the circumference. So that's kind of out. The other option is if I knew the central angle. So if I knew the central angle that intercepts it, so angle PON, then I can find the measure of that arc because I know those 2 measures would be equal. I don't know the central angle, but I do know the inscribed angle. And because I know the inscribed angle, the central angle, the measure of angle PON, will be equal to 2 times the inscribed angle, which is 2 times 68. Or 136 degrees. And because I now know my central angle, I can figure out my minor arc. So now we're getting into more complex things because I'm not just using one angle property that will always be super obvious to me. I might have to find a middleman to go through if I can't get all of the way there. Okay, next, I want to find the measure of angle MNP. What color haven't I used yet? Orange? MNP. So M to N to P. Now that's an inscribed angle, which is cool. I don't have another inscribed angle that opens to arc PM, but I do notice that, what color here? It opens to this diameter, or it's an inscribed angle of a semicircle. And if I'm an inscribed angle of a semicircle, property 3 tells me that the measure of my angle must be 90 degrees. Okay, 2 left. We can do it. Let's go, team. All right. Next, I need a new color here. I want to find the measure of angle LOP. Now, angle LOP isn't actually labeled on here, but LOP. And when I'm taking a look at this angle, I don't know much about it. It wasn't even drawn in. I don't know its inscribed angle measure, but I do know the measure of the arc that it intercepts. And from the previous lesson, we know that the measure of the central angle is equal to the measure of the arc that it intercepts, which means that central angle is 92 degrees as well. All right, last one. Measure of angle LNP. L to N and N to P. Well, that's an inscribed angle. It's made out of 2 chords. And I just figured out the measure of the central angle that intercepts the same arc. And the inscribed angle will be half of that size. So if I have in central angle LOP being 92 degrees, then half will be 92 divided by 2, which is 46 degrees. All right, this question was quite a lot, mostly because there's a lot of different things we asked about on this one question. But it also talked about a lot of the angle properties that we introduced today and some of the angle properties with the arc that we talked about in previous sections. So very exciting times. All right, that is it and that is all. I hope you have a wonderful rest of your day. Bye.